Hello, everyone. Thank you for joining us. My name is Katie Stolman. I'm with O'Reilly Media, and I'll be your host for today's online event. We'd like to begin our webcast by saying thank you to our sponsor, Sumo Logic, and let you all know that Sumo Logic is the industry's secure, cloud-native data analytics service delivering real-time, continuous intelligence across an organization's entire infrastructure and application stack. More than 700 customers around the globe experience real-time operational, business, and customer insights using Sumo Logic for their DevOps, IT ops and security, and compliance use cases. With Sumo Logic, customers gain a service model advantage to accelerate their shift to continuous innovation, increasing competitive advantage, business value, and growth. Thank you again, Sumo Logic. Today's webcast, Operational Visibility from AWS, Insights from the Cloud, is being presented by John Gallagher. John is an AWS Certified Solutions Architect, an AWS Certified DevOps Engineer, and a Google Qualified Developer in App Engine, Cloud Storage, Cloud SQL, BigQuery, and Compute Engine. He holds an MBA from Thunderbird School of Global Management and a BS from the University of California, Berkeley. I'll turn the program over to John in just a moment, but first let me go over a few things to help you get the most out of today's event. First, you'll want to open the group chat widget if you haven't already done so. This is where we'll interact with each other during the event and where you'll submit your questions for John. We find that our audience usually has a lot of good knowledge to share, so we encourage you to chat freely during the event. However, if you have a question for John, please preface it with a capital letter Q so we can make sure he sees it for Q&A. You can also open, move, and resize any of the other widgets. If you'd like to tweet from the Twitter widget, you'll need to give it permission to access your account. Our hashtag today is AWS, and the Twitter widget will automatically append that to your tweet so you don't have to. If you have any problems during the event, we encourage you to look at the help widget, which is very thorough. But if you continue to have problems, post in the chat room and one of our staff will help. For choppy audio or stalled visuals, try refreshing your browser window. And remember that the best thing you can do for a good audio stream is close any apps that could be interfering. We are recording this event, and we'll send an email to everyone who registered when the recording is available, and that's usually within 48 hours. And at this time, I'd like to turn the program over to John for his presentation. Hi, John.
Hi, Katie. Thank you very much. I usually never have someone say such nice things about me other than my mother. Okay, everyone. Thanks a lot for joining us. I see we're scattered around the globe, and hopefully we're all looking for ways so we can use the cloud more effectively, or maybe we're looking to see if we need to use the cloud. What I want to talk about today is the process of getting insight, of seeing what's happening within your systems. The cloud makes that exceptionally powerful to do, but with any power comes a lot of framework, a lot of things to control it. And so we'll be talking about operation and visibility itself. We'll be talking about the process of using operational visibility, and then we'll be talking about frameworks that allow us to get this operational visibility. So what we're going to be talking about today is obviously what is operational visibility? What do we use it for? And how do we use it? And then in terms of AWS, what are we going to use operational visibility for? What data does AWS give us that allows us to get operational visibility? And given that we probably have goals, we undoubtedly have goals, how are we going to use operational visibility to achieve those goals? So what is operational visibility? I don't like formal definitions. I like to have definitions that I can remember. Very small mind with a lot of things going into it. So what I think of it in terms of is make what is happening in the system and what is currently happening in the system accessible and understandable. And in order for something to be accessible and understandable, operational visibility must, collect the data. Collect data about what's happening in your system. It has to store that data. And this is kind of it's an assumed process, but it has to store this data so it's retrievable, so it's manipulable, and so that we can reference it on various periods of time. That we've stored the data, for example, that we can collect in real time and display it. We've also stored it in such a way we can go back and get some insights into what's happened to us. And then finally, we need to be able to present the data in context. Human beings cannot look at lists of lines of text and understand what's going on. We're not built that way. What we need to do is have visibility systems that help us understand what's going on with our systems. So operational visibility in the past, which could be 5 minutes from now, but more likely 10, 15 years from now, previous, was basically alarm management. Hey, something's gone wrong with our system, we need to respond. So those of us who've worn pagers throughout our careers understand what we're doing here. What we were trying to do with operational visibility is get to the heart of whatever was going wrong and allow us to solve the problem quickly. And then hopefully take what we've learned in solving the problem and prevent it from ever happening again. But what we want to do now is use that operational visibility to understand our system, to understand what's happening in it, who's using it, why they're using it. Obviously, we want to use OV to find and fix problems, but the key is continuously improve. You come up with an app, you come up with an enterprise application, you come up with a website. And day one, it's probably a great thing. People adopt it, people are integrating with it. But day two, you have competitors. And they're looking for any sort of opening in your system, anything that they can exploit to create their own products. So in order for you to stay level and improve, obviously, you're going to need to continuously improve. You're going to need to see into your systems and say, what are the things I need to change today that's going to put me in a more powerful position tomorrow? There are three basic areas that we want to make sure we're doing continuous improvement on. Cost. We want to make sure that we're spending our money efficiently. Performance. Now, performance could be anything from how fast does my web page load to is my application available to my users. And security. Now, particularly in the cloud, you start off with a public perception that the cloud is insecure. When you explore the cloud, you realize that you have the capability of making it far more secure than a physical system could be, but you can't get away from the fact that people have an initial impression. So security has to be job one, and it has to be part of every decision you make. As a matter of fact, all three of these need to be part of every decision you need to make. The classic thing you see up on a wall that says good, fast, cheap, pick any two, no longer applies. If you're going to run successful systems, applications, enterprise, websites, whatever you're doing, you're going to have to optimize all three of these directions at once. So how do we improve? What's the process that we're going to be going through here? Basically, it's two steps. We're going to measure, which means that we're gathering data, we're collecting data, we're storing data, but we're at the same time comparing that data to a benchmark. For example, you collect system uptime of 86,400 seconds. That's great. Your system's been up 86,400 seconds, but what does that mean? Was that 86,400 seconds this month? Fabulous. You were up 100% of the time this month. Was it 86,400 seconds this year? That's not so good. You're only up 12% of the time. So anytime that you're collecting data, you have to measure it by comparing it to a benchmark. Then once you've measured the data, you have to manage. You have to say, based on the measurements, based on what it's telling us, What do we need to change? Now, the process of doing something like this comes down to, if you can't measure it, you can't manage it. And if you're not measuring it, you're not managing it. So what are we doing when we're trying to do this? What are we actually, those are great principles, but what do we actually do to make sure we're doing it? Well, let's break it down to a 4-step process. Let's say A, let's figure out what's going on. B, or number 2 here, actually on the slide, determine whether the situation is good or bad. And 3, decide whether to change the situation. And 4, act based on the decision. In other words, this formally is known as an OODA loop: observe, orient, decide, and act. Now, OODA comes out of research by a guy named Colonel John Boyd, who was with the United States Air Force. His concern was to be able to help people understand what happens in air-to-air combat. Pretty much the most dynamic thing that you can be in. You're guiding vehicles that are traveling 600-700 miles an hour and attempting to kill each other. So if you do not have an awareness of what's going on, if you do not have the information you need in order to make a decision, if you don't decide and act quickly, you're going to be shot down. Going from that extreme, though, we find that the OODA loop works really well for managing any sort of dynamic system. So if we're looking at, let's say, managing a software system, our observation phase, we're going to monitor a system in comparison to benchmarks, noting not just where we are right now, but what are the trends. Then if we observe something that's out of whack, that's out of line with our benchmarks, we're going to orient ourselves. We're going to gather information that puts all that observation into context. And then once we've finished the orientation phase, once we have the information, we're going to decide what to do, and we're going to act. Now, this is something that's happening continuously and needs a good framework, needs good data in order to make sure our OODA loop is executing for us. So let's work through an example. You're sitting around a table and someone has a brilliant idea. You know what would make us literally dozens of nickels? How about a website that shows cute pet pictures? And everyone around the table says, brilliant, because of course, no one's ever thought of that before. So, luckily we know how to do this. Let's create a website. So we go out, we get a web server, we configure a web server, we load the website, and what do you know, it works. And as a matter of fact, this website does exist. It's called qtpetpics.com, and it's 3 pictures of my pets. As you can see on the picture here, that's Jax and Harry. Jax is a little min pin Chihuahua mix, and Harry is what's called a Xolo Itzcuintle, or a Mexican hairless. So he has an ironic name. Okay, so we have this website up. It's working. Yay us. Now let's go through the process of figuring out how we can decide what's going on with the system. What sort of data are we getting? So if this was a traditional system, then we would have a box that would be telling us things like, hey, the Apache log looks like this, the var log messages from Linux look like that. We may be able to decide what the operating system status is for things like ping and such. So we can get some good information here. We can figure out what's happened based on the logs, what's currently happening based on status from the operating system. But if we're running this in the cloud, and in particular with Amazon Web Services, we have the opportunity to tap into far richer data sources. The Amazon Web Services is manipulated by API calls. So everything you do in Amazon Web Services is an API call, so we can track who made that API call. We can track whether the API call succeeded. And we could figure out, based on errors, based on success, whether our system is being manipulated the way we want. So we don't have to do things like figure out who logged in. We actually know who logged in. We know who made that call. So we can track at the API call level. And above that, because all of this is running in AWS's own software, AWS is giving us metrics that we can figure out what's going on with our systems. Everything that started for you within AWS is a software instance that's running on something that's typically running on a hypervisor. or some other issue or some other service. So as a result, Amazon has this rich set of data that it can tap into to figure out what's going on with it. And it exposes that data for us. So now, instead of just having the information that we would have from a normal server, on the right-hand side again, where we have the operating system and application logs and operating system status, on the left-hand side, we can have a product called CloudWatch that gives us things like how much CPU are we using, how much disk are we using, I'm sorry, what's the I/O with our disk, what's our network I/O. And underneath that, we can keep track of the API calls that have created this and that are manipulating our resource. So we can get the 5 W's, the who, what, when, where, and why of someone firing off an API call. We can figure out whether something succeeded or failed, and then we get the full context of the API calls itself. So we have 3 dimensions of data that AWS is going to collect for us. So the 2 products I mentioned, CloudTrail and CloudWatch. CloudTrail is what records the API calls. It records every API call in a region for us, and it stores the output in an S3 bucket. The output contains the complete context for the API call. So who made it, what permission level they had, what arguments they made for the API call, and then the result of the API call, whether it succeeded or failed. If there was an error, it'll tell you why the error occurred. CloudWatch, on the other hand, is once we have a resource running in AWS, it automatically starts generating performance metrics. And CloudWatch will collect those for us, and it does that automatically. So CloudWatch automatically, and for free, by the way, is collecting these metrics to give us an idea of how things are working within our system. No matter how much we're running within AWS, it'll store the metrics for it for 14 days. And then we can export that data in CSV format. So you can see that our data is starting to grow here. And it's growing in different directions, in different places. So now what? We have our system running. Let's do something simple. Let's detect on our web server how much disk space do we have. And we look and we see, uh-oh, we've used up 15% of the disk space, and all I have are 3 pictures. Since I hope to have many thousands of pictures, millions possibly, because I'm going to dominate that cute pet picture market, that's not going to be enough. That's not going to be enough space. So we observed what our current state is. We oriented ourselves to decide whether that's a good state or a bad state. And we've determined that's probably not a good state. That's not enough. So what can we do? Well, if this was a traditional web server, what we would do is add more disk space. And since your server can look exactly like a traditional server in AWS, you could do that. You could use the Elastic Block Service and add more disk space. But now we need to think like we're in the cloud. We need to take advantage of the fact that we can break stuff apart, that we can do our storage separate from our computing. So we could use a central storage facility like the Simple Storage Service. So things like our pictures, things like our CSS files, they can all go into a central place and be stored for us. And rather than having to add more capacity on each individual web server, we're going to have a central place that people can look at. So we decided, let's use S3. And we're going to act. We're going to create an S3 bucket. We're going to upload the images to the bucket. We're going to change the website to use images from the bucket. So the result is something that looks like this. We have the web server still providing the logic, which says which picture, what IP address, what format, but the images themselves are coming from an S3 bucket. And all we had to do in our HTML was change one line of code. So we went from the top line there, where we have our images sitting in a traditional directory, to the bottom line, where instead of looking at a local directory, we're requesting it via standard HTTP from our S3 bucket. And behind the scenes, we're going to have something like, we're going to have security policies. The security policies can make sure that anyone accessing this bucket has to come from this website. So we have increased our performance. because we won't run out of disk space. We've decreased our cost because EBS storage, elastic block storage, that costs you 10 cents per gig, no matter what you have stored in it. Whereas storing something in S3 costs you 3 cents a gig, and you're only paying for what you're actually storing. And security, where we're making sure that the S3 bucket has a definable path that only allows access through that path. So we're optimizing again along those three dimensions. Okay, now that we've set this up, do we have additional data? Yes, we do. S3 itself generates logs. Now these logs can track who's accessing a particular object, whether they're allowed to or not, what time, what IP address, etc. So note that as we add more resources in the cloud, we're getting more data. Okay, now what should we do? Let's target things like cost specifically. So we started off using, in AWS, we started off using a pretty standard box. It's called an M3 Extra Large. It goes for 26.6 cents an hour. But in looking at this dashboard here, and looking at this information that's coming to us from CloudWatch, we realize, and I'm sorry it's a little hard to read here, that blue line under CPU utilization, it never goes beyond 0.16% of the CPU. In other words, we're never using all that capacity. So we've observed, hey, we're not using all the capacity. What should we do here? The idea then is say, okay, since we're not using all the capacity, let's dial it back. Again, we're in the cloud. We're not tied to a specific box just because we bought it. We can jump in between different instance types. Instance type is basically defines the size of box we're running in the Elastic Compute Cloud or EC2. We can jump between the various instance types to find an instance type that matches our needs and our cost structure. So we're going to go from an M3 large, actually, at 26.6 cents an hour. We're going to go to a T2 micro, which will cost us 1.8 cents an hour. We also say, hey, if we're going to do this, let's make our system more flexible. Let's give it more ability to deal with growth and capacity. So what we're going to do then is we're going to take our region. We're running in Oregon. I'm in Portland, Oregon, and so we're always an Oregon booster. But one of the things that's great about running things in the Oregon region is that we're 100% carbon neutral. We only use hydroelectric power here. So if you need to have that as part of your marketing, that's a great thing to have. So we've decided we're going to be in the Oregon region, and we're going to build our own virtual private cloud. So we're going to create our own section of network within Amazon's software-defined network that's completely under our control. We're obviously going to allow it to talk to the internet. That's what that cloud icon is on the left. And then within our own section of the network, we're going to create a public subnet, which allows traffic to go into and out of the internet. And we're going to create a private subnet. Private subnets are neat because computers that you put inside, or instances you put inside the private network, are completely inaccessible to anyone who's not in the network itself. So if you put something in a private subnet, the outside world is not going to be able to access it. So we decide that we want to make sure that we're using public subnets in every one of these availability zones. So that dashed orange line represents what Amazon calls an availability zone. Availability zone, think of it like its own data center, is a completely independent physical facility within a region. So you can see there's 3 in US West 2 here, or the Oregon region. If something happens to one of those AZs, then it does not affect anything in the other AZs. You can have a availability zone that shuts down due to lack of power, due to some sort of earthquake, or some sort of catastrophic event. If it takes out an AZ and you are running your own compute jobs in multiple AZs, then your compute jobs continue, the ones that are not in the affected AZ. So you automatically get high availability by using systems that are in multiple AZs. So we're going to take advantage of that. And then finally, what we're going to do is use Amazon's elastic load balancing system. which means traffic from the internet will flow through the elastic load balancing system and then reach our web server. The advantages here are that we get better security because there's no access to our web servers. The traffic flows into the elastic load balancers that are on our public subnet, but traffic from the internet cannot reach our web servers directly. So we have a nice little cutout there. The other thing is the elastic load balancer costs us 2.5 cents an hour plus whatever data transits the elastic load balancer. So no matter how much traffic is going to move through here, the elastic load balancer will only cost us 2.5 cents an hour plus the bandwidth charges. So we're going to be able to scale our system without having to invest in more equipment and more instances. The elastic load balancer is better security, better cost, and better performance. So we've built all this. We're going to put a single web server behind that. And now for 2.5 cents plus 1.6 cents, we have a system that operates just as effectively and can scale better than the system that costs us 26.6 cents. So now that we have this infrastructure, if we ever want to grow, then what we can do is just add more web servers in the private subnets and have the traffic come through the ELB to reach them. So what data do we have now? What kind of how are we monitoring this system? Well, the elastic load balancer itself, it has data that's coming from CloudWatch saying how many healthy hosts is it talking to, what's the latency of requests. It also generates its own logs. So logs that look in many ways like a web server log that tell you who is accessing our system, what requests they made, and when and where it happened. The VPC itself is creating logs. You can tell the VPC to track the connections between any entity within the VPC. And the VPC will tell you, someone tried to connect to this box on port 22 via SSH. Well, there's no SSH open here, so it was denied, so you can keep track of people who are trying to break into your system. So look at all the data that we're accumulating every step of the way. We started off with the data from the web servers in lower right-hand corner, then the S3 logs. We're accumulating more with the ELB, with the flow logs. Where are we right now in this process? Well, more resources make more data. Also remember, every API call produced an entry in CloudTrail. So when we made the call to create the ELB, we have entries in CloudTrail. So what are we doing with the data right now? Well, right now we're just collecting it. And so far, we've lucked out. We've happened to look at the right thing at the right time. But we don't have something that's telling us what's going on. Now remember, collecting data is not measuring or managing. Those are the two things we've got to do. We've got data. We have to measure it by comparing it to a benchmark, and then manage by making decisions. So what do we do here? We need to automate. Human beings, human perceptions, human fingers are not going to be able to catch up with the amount of data that's being presented for us. So what we need to do is have an automatic system that's collecting the data for us, that's storing the data for us, and that's putting that data into context. Remember those three things that we have to do in order to get meaning out of it. So there's three approaches to automation. We can build the system ourselves, DIY. We can take an open source approach, or we can purchase something from a third-party system. When we are looking to choose automation systems, you need to step back and understand exactly what you want out of the system. Every time you're going to look at a framework or a system to help you manage operational visibility, you have to go through the process of planning it out. You have to analyze what you want, and you have to research. Once you obtain a system, your job's not done. You have to constantly evaluate what you're getting from the automation systems. So day one, you're getting a set of reports. Are those reports doing the things that you need? Is it collecting the data in a timely enough fashion? The third thing, and possibly the most important thing, is that your job is to manage your own system. Your job is not to manage the automation system. So you do not want to have staff whose talents and resources could be applied to making your systems more effective. You don't want to have them dedicated to managing an automation system that isn't adding to your bottom line. So what are the pros and cons of each of the three approaches? DIY. It may address every unique problem you have. So it may be the way to get a hold of exactly what's going on with your system. That being said, you're running three kinds of risk here. The main one is you do need an automation framework, and you need it sooner rather than later. If you are trying to create it yourself, you probably won't have it in time to create. You won't have time enough to create what you need, and what you do produce won't be in time for what you need it for. Sorry, the slide keeps flying back here. Okay. In addition, as I said earlier, you may not have the resources to create the technology. Are you a systems monitoring company? Or are you an applications game company, a enterprise? And then finally, opportunity cost. You're giving up focus on your system, on your product, in order to create this one. And then finally, and this is difficult for a lot of people to get their heads around, your problems may not be as unique as you think. Unless you're someone like, let's say, a Netflix, people have gone through this before. You probably want to leverage their experience and get an idea of what they've done and follow their path. So that brings us to, if you aren't going to write it yourself, two things you could probably do is take an open source approach. The advantage here is that a system that can do what you want probably already exists. Also, any decent open source system is going to have a good user community. A group of people, groups who've come together and figured out how to do stuff with it. So those address the problem of whether you're trying to write it yourself, whether you have the experience to do that, and also people who've done it before, helping you along. The problem is you have to implement it yourself. You have to build the systems that run all of this. And so again, you're running the same sorts of risk. Schedule. You're probably going to need the system before it's ready. Resources. Do you have extra resources sitting around? I know the companies I work with don't. We're all desperate to get people on board who understand this stuff. And then finally, opportunity cost. Don't minimize the effect of your management perspective. So even if what you're doing is just managing this product, the cycles you're giving up in making sure that this system meets what you need are probably cycles that you could have used on your own product. And then finally, if you do have to bring up the open source system, you will still have to dedicate resources to keep it running. So you will accumulate skills and knowledge that aren't necessarily in line with where your systems and applications are going. So finally, the third-party approach, buying something from professionals who've created these frameworks before. Advantages, the system probably already exists that does what you need. The right system is not going to take your resources to run. It's not going to take your resources to make sure, for example, there's enough storage or there's enough compute capacity. The right system, you're going to find answers to questions you haven't asked yet because they've built in experience of using the product across a wider swath of people. Disadvantages, obviously, monetary cost. Writing that check every month has got to be painful. You need to balance what you're paying for the system versus how much it would cost you to develop it yourself or maintain it yourself. You're still running three kinds of risk. Acquisition. You need to make sure that the software you buy is the software that matches your need. That is a non-trivial effort, making sure that you understand your needs enough to make sure that your software matches it. Resources, less of a problem with the previous systems, but you still need to train your staff on the system. And then stasis. you need to make sure the system can grow and change with you. You need to make sure that you see the development history of the product and that it matches what AWS is doing and also what you want to use AWS to leverage. So as I said before, we need to make sure it's all automated. Cloud systems are going to create too much data for us. Human perception, as I also said before, we're pattern-based. We can't look at lists of data and get meaning out of it. We have to see a pattern. We have to see a picture. Sometimes we impose patterns on things that aren't there. For example, seeing historical figures burned into various bread products. What we need to do is have a balance between our perceptions and the data that's being presented to us for analysis. So a computer is the best thing to do this for us. A computer that will run through the data, present it to us in a pattern that we understand. Okay, so given all that, what's the process of choosing your monitoring system or choosing your approach? Write down your requirements. If it isn't written down, it's not going to get done. If it isn't written down, no one else is going to understand it. If you can't explain what you want, then you don't really know what you want. So all these things factor into the process of getting this system. Some of the requirements you might want to consider: where does the system run? How much does the system store for you? How much history are you going to be able to retain? How many people can use the system at once? Is this something that necessarily needs to be run by a core few of people, or is this a tool that can be generalized enough to be put down on a, let's say, a data scientist's desk? So if your product or system has a big data component, maybe use the same skill set in order to look at your own system. Once you've written down the requirements, make sure everyone knows what those requirements are. Make sure that everyone is aware of what we're looking for. When you're looking at a system, DIY, open source, or third party, test it against the requirements that you've developed. Now, in an ideal case, in AWS, you want it to be native to AWS itself. In other words, they're eating the same dog food you are. So they're the ones that are going to find problems or solutions before you even run into them. Because ideally, both open source and third party is driving ahead of its user needs. So in the case particularly of third party, you want them to have picked up on the fact that changes occur all the time in AWS, and that they're ready and able to add more capability to their system when Amazon introduces them. You need to look for a system that operates like AWS, that constantly is expanding, is expandable, and takes advantage of the fact that you can use different services, integrate different services together, and not be locked into a one box, one data store type technology. And then finally, when you're looking at the requirements, you should use Amazon's own tools for comparison. If CloudWatch has visualization, as we saw in that CPU utilization graph, compare what CloudWatch can do versus what you're looking for, and look to see that you get a deeper and richer set of capabilities. Okay, so what I'd like to do is do a quick demo of Sumo Logic. Sumo Logic, in addition to being obviously a sponsor of this webinar, is a really powerful system that integrates, both runs on AWS, but integrates all the AWS resources necessary to get a view. As an example, when VPC flow logs came out, that was a brand new product and a brand new approach. Sumo Logic was the first one to have a integration for the VPC flow logs product. So I like it because it both integrates with AWS and is definitely not in stasis. I created an account to monitor qtpetbix.com. The sign up was maybe 5 minutes. The system gives me a fast time to retrieval, and obviously the system itself is ready. It was ready to go to integrate with AWS. So I literally did this, I think Tuesday of this week. So here's the process of bringing in the Elastic Load Balancer logs. I picked the ELB, and I'll show you why when we get to the Management Console, because I think of the ELB logs as pretty much an untapped resource right now as far as insight into your system. AWS does collect the logs for you, but it doesn't have an interface natively for you to do anything with the logs other than list them. But using something like Sumo Logic, we're able to bring those logs into context, and we do that through the screen you see here. We say, I want you to collect ELB logs for us. Note here at step 2, this is a really powerful integration with AWS itself. So it's going to ask us for an access key and seeker key. And in the area highlighted in blue, it's telling us exactly how to set up the permissions so that they have access to the ELB logs, but nothing else. So this is out of scope for us to talk much about the security provisions here, but basically what we have in the blue is what's called an IAM security policy. And this IAM security policy says that the only things that Sumo Logic is going to be able to do is to get an object, in other words, read the file-like thing from S3, get the version of the object, list the bucket where the object is contained, and list the object versions. So those 4 commands are the only thing that this identity is going to be allowed to do. That's really powerful. It's a really safe way of doing stuff. So you can see here on this screen, I've added the access key. And sorry, folks, I'm not going to show you I did the secret access key, and I'm not going to show you the access key. I'm just that paranoid. And we're done. So 3 screens. About 2 minutes later, everything that was in the Elastic Load Balancer logs was sucked into the system and available for me to use. So let me show you what that looks like. I'm waiting here for the software to spin up so I can share my screen with you. Okay, you probably have a black screen here, and then we come up on the Management Console for qtpetpicks.com. As I said, it's a live site. This is the AWS Management Console. Gives you control of the resources underneath that. But remember, everything you do in AWS is an API, including using the Management Console. So what's happening underneath here is when you pick something and it does it for you, it's actually issuing API calls on your behalf. So in addition to everything else that you can do with CloudTrail, you can monitor people's use of a graphical user interface. So from here, what I'd like to do is look at that load balancer I started up. So on the lower left-hand side of the EC2 interface, we can see the load balancer. I'll click on that load balancer, and you can see I have the load balancers ready to go. And if we scroll down here, you can see that I've enabled load balancer logs. And these are being stored in this S3 bucket here. Now, if I go to S3, the simple storage service, you can see I have the ELB logs stored in a separate bucket. And we'll click down. The logs themselves are stored in a format which is basically saying account number, the type of product it is, so we could have multiple products here, the region that I'm running this in, and then the date all the way down to today. You can see that we're in October. We're down here on the 27th. So right now, the only thing that we're doing with the ELB logs is we're storing them. So we can look here and we see a bunch of text. Now if we look here powerfully, we can see some interesting things like we see some 404s coming from TwitterBot. So it's trying to get something that we don't have. It's trying to get the robot.txt. So that's interesting, but not really powerful. It also requires a lot of attention that I could have focused on another area. But since I sucked all this information into Sumo Logic, I'm able to do some really interesting things with this. So you can see on this page, I have my current status of people who've accessing the website based on geography. I actually don't think I'm going to get rich off this site. If something tells me that seeing 3 pictures is not the way to my retirement. But I see some interesting things here. I could see that I have traffic coming in from Asia, which I didn't anticipate. I don't have a whole lot of friends in China. Interestingly enough, my screen share decided to change. Go back to that. Okay, so I can see that I've got some traffic from China I didn't anticipate, nor did I anticipate the traffic from Europe. In addition, I'm seeing a lot of error traffic. So I'm in the observation phase. I observe anomalous stuff. Let's take a quick look, and because I'm interested in the geography of stuff, let's take a quick look and see where my history of requests have been. So what I'm going to do here is I'm going to run a request, or this ran a request for me, you can see. The language we see here is the data retrieval and formatting language internal to Sumo Logic. We can see that we start off with the source of the ELB logs themselves. We run a parse through it. Easier to understand if I bring up the actual entry. We run a parse where we're designating these entities and we're giving them variable names. So we have the time and date, we have the ELB server, we have the IP address of the client, the port, the backend, the response, the status code that was returned by the ELB, the status code that was returned by the backend. So in the case of the geolocation interface, what we're interested in here is we're going to look up the latitude and longitude based on the client IP, and then we're going to push that out as a count on the map here. Now we can see there's some really anomalous stuff going on. We have a lot of people checking in from Lithuania. Lithuania is a wonderful country, but I don't know anyone in Lithuania. And frankly, no one who doesn't know me really cares about my pets. So there's something going on here. Of course, Martine's people in Latvia are wonderful people. And I hope they see our pet pictures. But for some reason, the people in Lithuania really want to see my pet pictures. What I'd like to do is see what's going on. What are they actually trying to get? So I can take this search and ask myself, what is the actual thing or the actual command that they're doing to get this information? Now here we have the search interface where you can create your own searches into the data that Sumo Logic collects for you. I did this and I had a blank search, and what this does is show me all the data. So you can see things like the monitor that's on the Unix box is telling me that there was a message in the messages area of var log saying that there was a DHCP renew. So what I want to do is go into the Elastic Load Balancer logs, and I'm going to remove this lookup because in this case, I don't want to find out where things are. What I want to find out is what are the requests that people are making in order to access my system? Because what I'm really interested in here is why this is happening, these errors. So I'm going to make a quick search here. I'm going to count by the path, which is the actual URL. I'm going to get the status code for the back end. And I'm going to get the client IP address. So I've counted by this tuple here, and I'm saying I want to sort by count. So what this will do is count every time that the path, status code, and client IP are the same, and give me an idea of who's asking for all this stuff all the time. And let's do it over the last 14 days, just to give it a workout. So you can see that the system's returning answers to me really, really quickly, that it is examining, at this point, it examined 13,000 records. And I found, hey, here's an IP address that's asking for bogus stuff off my system. So let's create a dashboard off of that. I want to monitor that because it's entirely possible that someone's trying to break into my system. So what I did was I took that search, I clicked on the button that says Make a Dashboard, and now I have a dashboard. So it ran through the same search again, and I could see, you know what? It looks like that the person at 185.8.107.162 may be looking for weaknesses in my system. It's looking for index.php. Well, /index.php obviously exists. We get a 200 there. Index.php again exists. If they don't specify a particular file, then it exists because it defaults to index.php. But all of these other here, these look like someone looking for vulnerabilities in my system. And it looks like this has been happening a lot. So I've observed, I've oriented, I've collected more information. It looks like someone's probing me, trying to attack me. So then I could decide, hey, let's act. So I can take these IP addresses, and Amazon has a new product called the Web Application Firewall. And I could take these addresses and build a web application firewall and block those IP addresses. So you saw in real time how quickly the data got retrieved, the data got put into context, and the data gave me an answer I could act on. In addition, there's an entire audit path that I can follow that shows me what I did here. So this is the power of collecting the data, measuring the data, and acting on the data. And in order to do that, you're going to have a framework or an automation process that does that for you. So, and I've demonstrated that Sumo Logic is one of those, is a great framework for doing that. Okay, so that's it. Anyone have any questions about this process?
Let's give the audience a second. If you do have questions for John, if you could just open up your group chat and type the question in there, that would be fantastic. Looks like we don't have any questions. You must have explained everything to the audience perfectly, John. But thank you so much for presenting. Oh, wait, we do have a question. Hold on. Morgan is asking, is there a way for Sumo to push something back into AWS, say through SNS or such, to trigger an automatic AWS rule?
Yes, there is. Sumo Logic has an API that can do that. That's not something I've done myself, but I am aware of how that process would work, and I think that would be, I think SNS and SWF, as simple workflow, would both be great. The other thing that would be really good here is using a Lambda. So if we pushed into a Lambda, and had Lambda get the context of what we were trying to do. So, for example, the detection of the fact that we had those IP addresses that we're trying to break in, it would be a great interface for using Lambda.
Martin's asking, is there an agent that can push to Sumo Logic?
Absolutely. There are any number of agents, for example, Linux, Mac OS, Windows, that can push the internal context into Sumo Logic. As you probably, those of you who have experience with AWS know, CloudWatch can only tell you the external stuff. CloudWatch can only know how much CPU, network I/O, etc. CloudWatch can't tell you things like memory utilization. However, the agents that Sumo Logic provides can do that. They can run in the context of the operating system and detect things like out of memory or internal operating system conditions that CloudWatch can't really see.
Caleb asks, any resource suggestions for a higher ed institution considering switching from conventional servers to AWS? And by resource, he means literature to read up on.
Caleb, there's a lot of good stuff out there. Both Sumo Logic publishes a bunch of interesting use cases, and in addition, Amazon itself has some white papers and process for doing that. If you are an educational institution that would like to transition, both Sumo Logic and definitely AWS would very much like to talk to you on the process that going through that. So I would, Caleb, as a direct answer, definitely look at Sumo Logic use cases and look at AWS. Let me put this. Amazon has. Me typing is a bad thing.
I put a link to the Sumo Logic AWS page in the group chat.
Oh,
John.
Excellent.
Yeah.
I'm trying to spell architecture under pressure. For AWS itself, that link is a link both for information about architecture and reference architectures and pointers to use cases, which then can also tie back into monitoring systems like Sumo Logic.
Let's see, any more questions from the audience? Just open up that group chat widget and type them in. We'll give a minute or so to see if anything comes in. Well, John, I think that's all the questions that we have today from our audience. But thank you so much for being here and presenting such an outstanding webcast and sharing your knowledge and expertise with our audience.
Great, thank you all very much. It's been fun putting all this together. I hope I wish you great success in the cloud if that's a path that you're taking, and I hope some of this advice is useful for you.
We'd like to thank all of you that attended our webcast today and hope you've benefited from it. And as we close out, we'd like to say a big thank you to our sponsor, Sumo Logic, and let you know that Sumo Logic is the industry's secure, cloud-native data analytics service delivering real-time, continuous intelligence across an organization's entire infrastructure and application stack. More than 700 customers around the globe experience real-time operational, business, and customer insights using Sumo Logic for their DevOps, IT Ops, and security and compliance use cases. With Sumo Logic, customers gain a service model advantage to accelerate their shift to continuous innovation, increasing competitive advantage, business value, and growth. Thanks again for joining us, everyone. This will conclude our webcast today. Goodbye, everyone.